Kuru disease is a rare and fatal neurodegenerative disorder that primarily affected the Fore tribe in Papua New Guinea. This disease is a part of a larger group of conditions known as transmissible spongiform encephalopathies, or TSCs. TSCs are caused by infectious proteins, called prions, which lead to brain damage over time. Kuru gained significant attention in the 1950s and 1960s, when anthropologists and researchers studied the Fore tribe's customs, particularly their practice of ritualistic cannibalism, which contributed to the spread of the disease. Kuru was first discovered among the Fore people of Papua New Guinea. It is believed to have been transmitted through ritualistic cannibalism practiced by the Fore. This deadly disease affects the brain and nervous system, leading to a progressive decline in cognitive and motor functions. Kuru is a fascinating case study of how prion diseases can emerge and spread within isolated populations. Kuru is a rare and fatal neurodegenerative disorder that affects the human brain. It causes progressive deterioration of mental and physical function. Kuru is caused by infectious, misfolded proteins, called prions. These prions trigger the conversion of normal proteins into the abnormal form. Kuru was historically found only among the Fore people of the eastern highlands of Papua New Guinea. It reached epidemic proportions in this isolated region. Kuru disease is a rare and fatal neurodegenerative disorder that primarily affects the nervous system. One of the earliest and most prominent symptoms is uncontrollable tremors and a progressive loss of muscle coordination, making it difficult for patients to perform basic tasks. As the disease progresses, patients often experience slurred speech and trouble swallowing, which can lead to choking and malnutrition. Kuru disease also severely impacts cognitive function, causing memory loss, confusion, and eventually complete dementia. Involuntary movements, such as uncontrollable laughter or crying, and abnormal reflexes, are common as the disease advances. It's important to note the distressing nature of these symptoms and the profound impact they have on the lives of those affected. Kuru was a devastating neurodegenerative disease that primarily affected the Fore people of Papua New Guinea due to their practice of ritualistic cannibalism. The consumption of infected brain tissue during funeral rites led to the transmission of abnormal prion proteins, which caused the deadly effects of Kuru. Certain genetic factors, such as variations in the PRNP gene, may have influenced an individual's susceptibility to developing Kuru after exposure to the infectious prion. The remote and isolated nature of the Fore people's communities, as well as their limited access to modern healthcare, likely contributed to the spread and persistence of the Kuru epidemic. Understanding the causes of Kuru is important to prevent the spread of similar prion-based diseases and to develop effective treatments for neurodegenerative disorders. Kuru disease was first discovered and studied by a team of pioneering medical researchers in the 1950s. They observed the unique neurological symptoms that characterize the disease. The researchers traced the disease to a specific region of Papua New Guinea. They uncovered the connection between Kuru and the local practice of funerary cannibalism. This groundbreaking research helped identify the origins and causes of this mysterious disease. The Kuru epidemic was a devastating public health crisis that ravaged the Fore people of Papua New Guinea in the mid-20th century. Kuru was a fatal prion disease that spread rapidly through the remote highland villages due to the Fore's traditional funeral rites involving the consumption of deceased relatives. Mortality rates from Kuru reached as high as 2% per year at the peak of the epidemic, plunging isolated Fore communities into crisis. The unique cultural and geographic factors of this region, including the traditional funeral practices, contributed to the rapid transmission of Kuru throughout the population. This slide provides an overview of the Kuru epidemic and the factors that led to its devastating impact on the Fore people. The Fore people of Papua New Guinea practice ritual cannibalism as part of their cultural traditions, consuming the brains of their deceased relatives. This unknowingly led to the transmission of the infectious prion that caused the deadly Kuru disease, sparking an epidemic among the Fore people. The ritual consumption of the dead was seen as a way to honor and remember their loved ones, but tragically resulted in the spread of the Kuru disease. Kuru is a rare and fatal neurodegenerative disorder caused by the transmission of infectious prion proteins through cannibalistic practices. The Fore people of Papua New Guinea practice a centuries-old tradition of consuming the brains of their deceased relatives during funeral rituals. This cannibalistic ritual was the primary way that Kuru disease was transmitted through the population over generations. The infectious agent responsible for Kuru was later identified as prion, abnormal proteins that could trigger the misfolding of normal brain proteins. Kuru had an exceptionally long incubation period, sometimes up to 40 years, making it difficult to trace the exact source of transmission in many cases. Once the Fore people discontinued the ritual cannibalism practice, the Kuru epidemic was eventually brought under control and the disease began to disappear. Kuru disease is a rare and fatal neurodegenerative disorder. It is characterized by an exceptionally long incubation period, ranging from 4 to 40 years. This extended incubation time is a hallmark of prion diseases, where the infectious agent takes decades to cause clinical symptoms. The slow replication and spread of the infectious prion within the host's body before reaching the brain is what leads to this protracted incubation period. This lengthy window has important implications for diagnosing Kuru and understanding how it is transmitted. Kuru is a rare and fatal neurodegenerative disease characterized by progressive damage to the brain. The key pathological features include extensive neurodegeneration, particularly in the cerebellum, brainstem, and other parts of the central nervous system. Spongy degeneration of brain tissue, creating a Swiss cheese appearance under a microscope. Abnormal folding and aggregation of prion proteins, leading to the buildup of insoluble deposits in the brain. Significant loss of neurons and proliferation of glial cells, contributing to the severe neurological symptoms. These pathological changes ultimately result in the devastating neurological effects seen in individuals with Kuru. Kuru was a devastating neurodegenerative disease that primarily affected the Fore people of Papua New Guinea. Autopsies of Kuru victims reveal extensive damage to the cerebellum, a key part of the brain. The cerebellum showed significant neuronal loss, gliosis, proliferation of glial cells, and the formation of amyloid plaques. These amyloid plaques were composed of abnormally folded prion proteins, which were a hallmark of Kuru. The buildup of these prion protein aggregates contributed to the progressive neurological decline seen in Kuru patients. Understanding the neuropathological changes in Kuru was crucial for unraveling the underlying mechanisms of this mysterious disease. Kuru is a rare and fatal neurodegenerative disease caused by infectious prion proteins. Prion proteins are the key agents responsible for transmitting and causing Kuru disease. In Kuru, these prion proteins misfold into an abnormal shape, forming infectious particles. The misfolded prion proteins can then cause normally shaped prion to also misfold, leading to rapid propagation of the disease throughout the brain. This process of misfolding and propagation is what makes Kuru so devastating and difficult to treat. Kuru is a rare and fatal neurodegenerative disorder caused by misfolded prion proteins. These misfolded prion can propagate and induce the misfolding of normal prion proteins in the brain. The infectious prion can be transmitted through exposure to contaminated tissue, leading to the spread of the disease. The misfolded prion trigger a cascade of events that result in neurodegeneration and the clinical symptoms of Kuru. The replication and propagation of prion within the brain is a key mechanism underlying the progression of Kuru. The Fore people of Papua New Guinea practice a ritual called cannibalism, where they would consume the brains of their deceased relatives during funeral rites. They believe this practice would allow them to honor the memory of the deceased and absorb their strength and wisdom. However, this practice unwittingly facilitated the transmission of Kuru disease, as the prion responsible for the disease were concentrated in the brain tissue. The spread of Kuru disease was directly linked to this traditional cannibalistic practice among the Fore people. This cultural ritual, although significant to the Fore people, had devastating consequences in terms of public health due to the transmission of the deadly Kuru disease. Kuru is a rare and fatal neurodegenerative disease caused by misfolded prion proteins. Diagnosing Kuru requires a thorough clinical evaluation of the patient's neurological symptoms, such as ataxia, tremors, and cognitive decline. Genetic testing to analyze the patient's prion protein gene can help confirm a Kuru diagnosis. Brain imaging techniques, like MRI and PET scans, can detect the characteristic brain lesions and patterns of neurodegeneration associated with Kuru. Detecting abnormal prion proteins in the patient's cerebrospinal fluid or brain tissue can provide a definitive Kuru diagnosis. Early and accurate diagnosis is crucial, as Kuru is a rapidly progressing and ultimately fatal disease. The image on this slide shows a remote village in Papua New Guinea, with the Fore people gathered in a clearing. They have somber expressions, reflecting the transition from traditional practices to modern public health interventions. The slide outlines 3 key factors that help curb the spread of the Kuru epidemic among the Fore people. Public health measures, the establishment of strict hygiene protocols and social reforms were instrumental in slowing the transmission of Kuru. Changing burial practices, a shift away from traditional endocannibalism, where the deceased were consumed, helped reduce the spread of the deadly prion that caused Kuru. Isolation and education, isolating affected communities and educating the Fore about the risks of ritualistic cannibalism were crucial steps in containing the epidemic. These interventions, though challenging, were essential in bringing the Kuru epidemic under control and protecting the Fore people. The practice of ritualistic cannibalism was the primary mode of Kuru transmission in Papua New Guinea. Banning this practice was a crucial step in preventing further spread of the disease. Extensive education campaigns informed affected communities about the risks of consuming human flesh and the importance of avoiding this practice. Ongoing surveillance, monitoring of suspected cases, and thorough contact tracing were crucial in containing the Kuru outbreak and preventing further transmission. Promoting better hygiene and sanitation practices, such as proper disposal of human remains, helped mitigate the risk of accidental Kuru exposure. Kuru research often involves studying the remains of deceased individuals, which raises ethical concerns around respecting the dead. As researchers, we must carefully weigh the potential benefits of our work against the risks of causing distress or offense to affected communities. Obtaining truly informed consent from research participants can be complex, as Kuru primarily affected remote indigenous communities. We must be sensitive to cultural differences and power imbalances to ensure participants fully understand and consent to our research. Kuru research has the potential to uncover valuable traditional knowledge about the disease. It's crucial that we share this knowledge respectfully and ensure indigenous communities retain control over how it is used. There is a history of exploitative practices in medical research involving vulnerable populations. As Kuru researchers, we must be vigilant to prevent the exploitation of affected communities, both past and present. Kuru disease was a devastating neurodegenerative disorder that affected the Fore people of Papua New Guinea in the mid-20th century. The discovery and study of Kuru led to groundbreaking advancements in prion science, our understanding of how these infectious proteins cause disease, and the development of new approaches to studying neurodegenerative disorders. Kuru had a profound cultural and social impact on the Fore people, with its devastating effects reverberating in their community to this day. Ongoing research into Kuru and other prion diseases continues, with the goal of developing effective treatments and preventions that can help those affected. The legacy of Kuru remains an important driver of critical medical research, as we strive to build on the knowledge gained from this tragic episode in human history. Kuru disease was a devastating neurological disorder discovered among the Fore people of Papua New Guinea in the 1950s. The study of Kuru led to groundbreaking research that revolutionized our understanding of infectious proteins, called prion. Kuru provided crucial evidence for the prion hypothesis, which challenged the conventional view of infectious agents and diseases. Investigations into Kuru helped develop new diagnostic techniques for prion diseases, improving early detection and management. Research on Kuru has informed the development of potential treatments for other fatal prion disorders, such as Creutzfeldt-Jakob disease. Kuru, a rare and fatal neurodegenerative disorder, provided crucial insights that accelerated research on prion diseases like Creutzfeldt-Jakob disease, CJD. The study of Kuru's transmission through ritualistic cannibalism helped inform public health policies and practices to prevent the spread of similar prion diseases. Research on Kuru contributed to the development of diagnostic tests and techniques that can be used to identify other prion disorders at earlier stages. Kuru, CJD, and other prion disorders are all caused by abnormal folding of the prion protein, leading to neurological symptoms like ataxia, dementia, and loss of motor functions. While CJD can occur sporadically, be inherited, or acquired, Kuru was exclusively transmitted through the ritual practice of cannibalism among the Fore people of Papua New Guinea. The Kuru epidemic was localized to the Fore region, unlike the more global distribution of CJD cases. The distinct transmission and epidemic patterns of Kuru compared to CJD highlight the unique circumstances that led to this prion disease outbreak. Prion diseases are a group of rare and fatal neurodegenerative disorders caused by misfolded prion proteins. Recent advancements in research have led to significant progress in several key areas. Diagnostic tools, new tests can detect prion proteins more accurately, enabling earlier diagnosis of these diseases. Therapeutic approaches, researchers are exploring novel drug candidates and gene therapies to potentially halt or reverse the progression of prion disorders. Prion structure analysis, advanced imaging techniques and computational modeling have provided deeper insights into the complex structures of prion proteins, which is crucial for understanding disease mechanisms. Animal models, improved animal models of prion diseases, are facilitating the study of disease pathways and the testing of potential treatments. These advancements are paving the way for earlier detection, more effective treatments, and a better understanding of prion diseases. Kuru is a rare and fatal neurodegenerative disease caused by prion. Research is focused on three key areas to advance our understanding and treatment of Kuru. Genetic insights, unlocking the genetic basis of Kuru to aid in diagnosis and treatment. Prion dynamics, deepening our knowledge of how prion replicate and spread in the body. Therapeutic interventions, developing new therapies to halt or reverse Kuru's progression. As our understanding of Kuru and prion diseases grows, the future holds great promise for major breakthroughs. Researchers are poised to make significant strides in all three of these critical research areas. The Kuru epidemic was a devastating prion disease that affected the Fore people of Papua New Guinea in the mid-20th century. It led to major scientific advancements in understanding prion diseases and infectious proteins, paving the way for further research into CJD, mad cow disease, and other deadly prion disorders. The Kuru crisis highlighted the importance of cultural sensitivity and community engagement when developing public health interventions. Researchers learned to collaborate closely with indigenous populations. Kuru research also raised complex ethical issues around informed consent, exploitation of vulnerable populations, and the boundaries of scientific inquiry. These discussions continue to shape medical research today. The Kuru epidemic left a lasting impact on the affected communities in Papua New Guinea, as well as the global scientific community. It serves as a sobering reminder of the devastating potential of prion diseases. The Kuru epidemic had a devastating impact on the Fore people, leaving lasting trauma for those who witnessed the horrific effects of this prion disease. The study of Kuru has been instrumental in advancing our understanding of prion diseases, leading to important breakthroughs that continue to inform treatment and prevention efforts for similar conditions. The Fore people maintain traditions and ceremonies to honor those lost to Kuru, ensuring the memory of the epidemic and its victims remains a vital part of their cultural identity. The Kuru disease has a very long incubation period, sometimes lasting for decades, before any symptoms appear. During this incubation period, the prion are replicating and accumulating in the brain, but the individual shows no outward signs of illness. Once the symptoms do start to manifest, they progress rapidly, often leading to death within a few years. This extended incubation period makes Kuru a particularly insidious disease, as it can spread through a population before anyone realizes there is an outbreak. Understanding this lengthy incubation period is crucial for identifying and containing Kuru outbreaks early on. Kuru is a rare but deadly prion disease that primarily affects communities in Papua New Guinea. Through educational campaigns and outreach, we can increase public understanding of Kuru and how it spreads, helping to prevent its transmission. Funding research on Kuru can lead to breakthroughs in diagnosing, treating, and ultimately eradicating this disease. Coordinating global efforts to monitor and respond to Kuru outbreaks is crucial for containing the disease and protecting vulnerable populations. By working together internationally, we can better protect communities at risk and work towards the eradication of Kuru. The 1997 Nobel Prize in Physiology or Medicine was awarded to Stanley B. Prusiner for his groundbreaking discovery of prion, a novel type of infectious agent. Prusiner's research focused on scrapie, a fatal brain disease affecting sheep and goats, which he found to be caused by these infectious prion proteins. His work revolutionized our understanding of infectious diseases, demonstrating that proteins alone, without any genetic material, can cause disease. Prion research has opened up new avenues in understanding neurodegenerative diseases like Alzheimer's and Parkinson's, which may also involve misfolded proteins. Prusiner's discovery was a major scientific breakthrough that challenged the conventional wisdom about the nature of infectious agents. The Kuru epidemic was a devastating disease that claimed thousands of lives in Papua New Guinea. We remember the victims with solemn reverence, acknowledging the immense suffering they endured. This tragic event has become a part of the cultural history of the Fore people, a stark reminder of the fragility of life. By remembering the victims, we can raise awareness about prion diseases and ensure their stories are never forgotten. The Fore people of Papua New Guinea practice ritual cannibalism as part of their cultural and spiritual traditions, which involve consuming the dead as a way to honor and mourn their loved ones. This practice, known as mortuary cannibalism, was deeply woven into the social fabric of the Fore community. However, this cultural tradition had a devastating consequence. It led to the emergence of the deadly Kuru disease, which shattered the Fore community and challenged their beliefs and traditions in profound ways. The Kuru epidemic left many Fore families devastated and forever changed, as they grappled with the societal impact of this tragic event. The Kuru epidemic was a devastating prion disease that ravaged certain populations in Papua New Guinea. This tragic outbreak led to significant changes in public health policies and practices around the world. One key impact was the implementation of strict measures to prevent the spread of prion diseases like Kuru. Regulations were also introduced to ensure the safety of food sources and ban the practice of cannibalism, which had contributed to the Kuru outbreak. The Kuru epidemic also spurred increased funding and investment in prion disease research, helping us better understand these deadly disorders. Additionally, the Kuru outbreak highlighted the need for improved global disease surveillance and early detection of emerging infectious threats. These public health advancements, stemming from the Kuru epidemic, have had lasting impacts on how we approach disease prevention and control globally. The Kuru disease was a captivating medical mystery that provided invaluable insights into prion diseases. Researchers' efforts to unravel the enigma of Kuru have led to a deeper understanding of these devastating conditions and their impact. The story of Kuru is complex, involving medical, anthropological, and ethical considerations. We hope you find this mini-lecture helpful in summarizing how the study of Kuru has advanced our knowledge in important ways.